Hello, everyone. Thank you for standing by. As a reminder, this event is being recorded and will be archived on pumpsandsystems.com. I'm Amy Hyde, editor of Pumps and Systems Media. Welcome to Pumping with VFDs Made Easy, sponsored by Ellis Electric. Our presenter today is Stephen R. Peterson. Stephen has been the manager of the technical department for Ellis Electric since 2016. Before that, he handled technical training, support, and repair for Yaskawa Electric America. Stephen holds a degree in electrical engineering from DeVry, and he has more than 18 years of VFD and control experience. At this time, it is our pleasure to begin the webinar. Stay tuned after the presentation for the Q&A session. Please send your questions through the Ask Question box, and we'll get to as many of them as possible. Now I'll turn it over to Stephen to begin the presentation.
Thank you, Amy, and good morning, everybody. So as Amy mentioned, my name is Stephen Peterson. I'm the application group manager over here at Ellis Electric America, and our topic today is pumping with VFDs made easy. So here's a brief overview of what we're going to be going through over the next hour or so. I'm going to start out with a little bit of an introduction to LS Group and LS Electric. Then we're going to go over the initial VFD settings for startup. And as it said in the title slide, it's going to be easy. So we're going to show you the easy set menu on the VFD screen on the keypad. We're going to talk about motor protection settings and option PID, which is proportional, integral, and derivative control. We're going to go overview of that. We're going to go through the setup parameters, and we actually have a demo that we're going to show you as well, a live demo. Then we're going to jump into lead lag setup, which is kind of more advanced PID with multiple VFDs, multiple pumps and motors. We're going to add on some additional pump protection features. And as Amy mentioned, we have a Q&A session at the end. So the first thing I just want to mention is who is LS Group? For some of you guys, LS Electric or LS may be a new name, but we've actually been around for quite a while. So a lot of people have heard of LG, as we mentioned here on this slide. They make washers, dryers, TVs, and items like that. Essentially, LS is a spinoff of LG, as LG got too large in Korea, so it got split up into three different companies. There's LS, LG, and GS. So LS Electric is part of LS Group, and within that LS Group, there's LS Cable and Systems, LS Mtron, and so on, as well as LS Electric. So LS Group globally, there's about 25,000 employees. LS Electric within LS Electric Group is about 4,300 employees, and it's a rapidly expanding number as we grow. And speaking of being around for a while, we just celebrated our 50th year anniversary. So LS Electric has been around since 1970. So with it being 2024, that is our 50-year anniversary. Got a little emblem of that on the left right here. So we consider ourselves one of the pioneers for electrical power systems, automation, and additional green energy. So we do have some DC devices that are, relatively new. What we're going to be focusing on is our automation side of the business, specifically the VFDs. As we mentioned, we're a South Korean company. So we have some maps that are going to come up within the next slide, so you can kind of see where everything's coming from. And I'm in our main headquarters, which is actually out of Lincolnshire, Illinois. So you'll see that in a map in just a second. So this is kind of our global operations map. So you can see there's a lot of stuff going on in, South Korea and the Southeast Asia area in general. If you look on the right side here, you have some offices in the U.S. So I'm out of our Lincolnshire, Illinois office, which is like a northwest suburb of Chicago. So we just say Chicago. This is also one of our warehouses. So we kind of do sales support, and we store our products here for shipping. And then we do some similar stuff on the West Coast in Southern California. We have our Western office. We have a new campus, which is down south in Bastrop, Texas, which is near the Austin area. And then we do have some other plants that are more power focused as well. So the main VFD we're going to be focusing on is the H100 Plus drive. So this drive is heavily geared towards pumping applications, which I believe everybody on this session right now is going to be most interested in. We do have some other drives. I don't talk about them, but we do have micro drives, the M100, the G100. We do have some general purpose drives such as the IS7 and the S100 as well. I'm choosing to talk about the H100 Plus because there's a lot of pump jargon in there. It's directed towards the US market, so there's a lot of easy things in there to do the programming, and that's what we're going to be jumping in. So I hope at the end of the session you guys see that it really is that easy to program this drive. So as mentioned, the H100 Plus is the series for pumping. It has an HOA keypad on it, so it does have a handoff auto keypad. So you're going to see some close-ups of that handoff auto keypad coming up shortly. It is our only drive that has a real-time clock, so there's some advantages of having a real-time clock built into the VFD we're going to discuss. It has specific pumping operations such as a pump clean operation. Some people call it like a DRAG. We have a broken pipe detection. We have a soft fill operation, which is great for irrigation, which large pipes and long pipes that will take a while to fill. We have a high and low feedback detection when you're running a PID control. We're going to show you an example of that later. We're also going to get involved with the lead lag multiplex, which is multiple pumps, multiple drives. As far as hardware, the H100 Plus does have a built-in EMC filter on the 400 volt series drives. So that's a C3 EMC filter. So that's for electromagnetic noise that the VFD may generate. I think you'll find most of this stuff is just industry standard as far as capacity. The H100 Plus is a dual rated drive. So you could run it normal duty or heavy duty, variable torque, constant torque. And if you haven't heard those terms before, it's an overload capacity of the drive. So most pumping applications are going to be normal duty, 110, 120% overload for 1 minute. So you could overload it for up to 1 minute. You could size the drive for heavy duty. So that may be used on piston pumps or reciprocating pumps. If you get involved with like compressors or stuff, that'd be another application where we'd size the drive for heavy duty. So we could do either or on this H100 Plus series drive. On the bottom left here, we kind of show you the spread of capacities. So for the longest time, the H100 Plus has stopped at 25 horsepower on the 200 volt class. Recently, and that's why it's in red here, we've expanded that from 30 horse to 125 horse. So if you have a larger capacity application, but you have 208, 230 volts, you could apply an H100 Plus on that. For the 400 volt class, for most, it's going to be 480 volts. We go from 1 horsepower up to 800 horsepower. One of the new series or capacities we've added is the 575 600 volt class. So that's 3-phase, 7.5 horsepower up to 125 horsepower. Additionally, we have all the standard control methods you may run into with any existing units that you may be utilizing. We default to a V by F control, so that's a V by F frequency control. So the output voltage going to the motor is determined by a predefined pattern of voltage over frequency, essentially. We do have a slip compensation. We also do have a newly added V by F control with permanent magnet control. So most of the time people are using induction motors, but if you happen to have a permanent magnet motor, we could run that off of the H100 Plus as well. That's a simple parameter that you enable. Standard protection degree on most of the drives is going to be IP20. You could make it NEMA 1 with a conduit kit. So if you're going to just screw the drive onto a wall in a maintenance room or something like that, or a pump house, a lot of times you'll get a conduit kit. So that's an add-on option. If you look on this picture on the right here, that's actually our disconnect option. So we do have disconnect options available. That's KEIC. So if you open up that box, you'd actually see an LS circuit breaker in there that's been combination tested with the drives. That's how we're able to achieve that high KA rating. So that's a nice option, especially if you need like a line of sight disconnect. And that actually gives you a NEMA 1 rating as well. So that's another option that's available. This is a globally certified product, but with us being US based, most of you guys are going to care about UL. So this does meet the new UL standard of 61800-5-1. Rated, CUL rated for Canada. We have CE, we have the RoHS, we do have a plenum rating as well. Additionally, all the PCBs, so all the printed circuit boards within the drives come standard with a 3C2 conformal coating. So if you're in some kind of environment that may be a little bit dusty or a little bit nasty, there is conformal coating on those printed circuit boards, and that's standard. It's not an add-on, that's just how they are. The last couple things I'll mention here is we do have some built-in communication protocols. If you get involved with HVAC, you may care about BACnet. BACnet MSTP is standard, as well as Metasys N2. We do have Modbus RTU, so if you work with more of like a more industrial protocol, we do have serial Modbus built in. And then we do have some option cards. We have a BACnet IP option card, a LonWorks option card, or most commonly, a lot of people are doing Ethernet now. So we do have an Ethernet IP option card, and that's just a field installed accessory. So you order it, you pop it in, and then you program it. Okay. So on the bottom here, you can kind of see the capacity ranges visually. And one other thing I'd like to mention, which especially with your guys' industry, you may find beneficial, is that we've done UL testing on all series drives, all capacities for single phase input. So we go up to 800 horsepower, 3-phase input on the H100 Plus. We have approximately a 50% D rate. So after we tested this with UL, you could take that 800 horsepower and get 350 horsepower out of it. So same thing for like a 10 horsepower. If you applied single phase to it, it'd be a 5 horsepower drive because you're only running a single phase input. So we could do that on any of our drives. It's all been UL tested. We have sizing charts on our website, Square, which we'll talk about a little bit later. All right, so that was just a big picture overview. So here we're actually going to dive into a little bit of the parameters. And as I mentioned, we tried our best to make it really easy. So that's the whole theme of this webinar here is it's really easy, even though a lot of times you work with a drive and there's 1,000 parameters, it's easy to get lost in the keypad and the parameter sets and the menus and the manual and everything like that. So what we have is we have an easy set. So when you first apply power to your H100 Plus VFD, you're going to see this pop up, which is on the right here. It says easy start, yes or no. We advise on clicking yes, because what it does is it takes you through this list on the screen here. So it takes you through some basic setup parameters, which includes like a macro setup. We're going to talk about that in a couple slides. A region, which is most likely going to be US. You set up your time, which we briefly mentioned. You set up your motor voltage and your incoming voltage and your motor current. And then you go on and set up your control and operation. Okay. And you pretty much just linearly go down this list, and then it's going to end with all these general protection features. And I have some slides that come up on pretty much each one of these. So we're going to explain why you set these and what they do and stuff. But you're going to enable like your phase loss detection. You might set up some automatic resets and fine tune what you want to happen if the motor overloads and stuff like that. So these are like general protection settings. So once you get through these 25 steps that initially pops up when the drive is powered up, you pretty much are able to run the drive. All your protection stuff in there, you have your motor data in there, your basic control stuff. So that's what we're going to focus on now. Okay. So the first thing that pops up is actually going to be your macro selection. And a lot of people are confused by this because they don't know what to pick. A lot of times though, people are just going to use a basic macro. Okay. So here we kind of explain what the macros are. So before we do that, I want to tell you that a macro is pretty much a predefined set of parameters that is meant to make life easier for whoever's commissioning the VFD and doing the startup, okay? So there's going to be some common parameters that are set up, and then it's also going to list all of those parameters in a macro list. So they're easy to adjust where you don't need to jump through 10 or 15 different groups. You just go down that list and you answer the questions, and then the drive is set up. So on the H100 Plus, we have 3 different macros. We have basic, pressure control, and lead lag. And we're going to be diving into each one of those. Basic is exactly as it sounds. It's a direct speed command. So that could be via keypad, presets, analog inputs, or communications. And then usually like a hardwired, run stop. So if you have like a control relay that starts the drive and you have a direct 0 to 10 signal or something, that would most likely be a basic macro. So you just leave it at basic. And if you look on this table here, it says that's the default. The other 2 are pressure control and lead lag, and they're kind of similar. Pressure control is actually called a simplex operation. So it's just one drive that's controlling motor speed based on a feedback device. such as a pressure transducer, maybe a flow meter, or a temperature sensor. It could even be like a level sensor, okay? So that's actually a PID loop that's happening within the drive. So we'll talk about that as we go along here. And the last macro, lead lag setup. So that's PID control, but it's multiple drives and multiple motors that are connected together. And in our case, we use Modbus to connect the devices together, the VFDs. And what it's going to do is once you set up all the drives for lead lag control in the macro, it's going to try to balance the system demand, alternate pumps, all based on what you program into the VFD. Okay, so I'm mentioning this first because after you hit yes for easy start, this is the first thing that comes up is what's your macro? Some people freak out because they picked the wrong thing, and we handle the tech support for the US, and people call up and say, "Oh, I picked the wrong thing." You can always go back and you can undo this. Don't need to buy a new VFD. You could always undo parameter settings. So this is the first thing that pops up. Okay, so those are macros, and again, we're going to dive into those a little bit further. The next few questions you're going to get as you're going through that linear easy start is what's your region? That's a pretty easy one. It's like putting your name on a paper when you're in school. If you get that wrong, you might have a problem. But most likely you're going to be in the US. You're going to select US. And what that does is it makes sure everything's in English. It sets up everything in horsepower, so all the American standard stuff. And then also it sets your voltage for American standard, like, 230, 240 volts. It'll set it to 480 volts on the 400 volt class. Otherwise, if you don't do that, you'll see defaults like 380, kind of stuff they're doing globally, not in the US. And then the next thing you'll do after that is going to be setting the date and the time. Okay. Simple enough. Put in your date, put in your time. But there is a trick is when you're doing this, there's a little plastic switch or a little plastic slip that's under a battery that's next to the keypad. We'd recommend removing that slip. Just like you purchase a toy at the store and there's a battery pre-installed, you need to remove that slip to make the battery make contact. Otherwise, you're going to lose that date and time after you cycle power to the drive. And this is a standard CR 2032 like coin battery, so it's like the size of a quarter. So we'd recommend enabling that battery after you set up the time when you're starting this up. Okay. So going on down the menu, so we're kind of on to the second group here, is all motor related stuff as well as incoming voltage. So when you're going to be setting up your motor parameters, we recommend either taking a picture or having another guy look at the motor nameplate and tell you everything. Okay. So here's a blown up picture of a motor nameplate. So in this example, we have a 3 horsepower motor. So on the top left, so that's the first thing you're going to enter is motor capacity and horsepower. The next thing is going to be your motor frequency, which most of the time is going to be 60 hertz. After that, you have rated current. And I always mention to people, this is one of the most important things because this sets your overload level for your motor. Okay, so if you have a 10 amp motor, you'd program 10 amps. So on this one, it's a dual rated motor. So it's 7.8 amps at 230 volt, and it's 3.9 amps at 460 volts. So to kind of dovetail into that, you're going to set your incoming voltage and then set accordingly based on what voltage you're running to the motor. Okay, so step 10 here is incoming voltage, which we recommend is reading that with a multimeter and programming it in. And then additionally, you have your number of motor poles. And a lot of times people say, oh, number of motor poles, and they think 3 because they're thinking 3-phase, and they go to set this, but it jumps from 2 to 4. We're not actually talking about motor phasing here. We're actually talking about electromagnetic motor poles. So if you have north-south, it's always going to be in pairs. So you're going to have 2, 4, 6. And I think most people, guys, are going to run in either 2-pole or 4-pole. A lot of submersible pumps are 2-pole, and that's because they're like 34, 3,500 RPMs. And then like centrifugal pumps and items like maybe vertical turbines and stuff, those are typically 4-pole. So it's actually based on RPM that you can see there's a formula here, which is your motor pulse is calculated by your frequency, 120, over your speed. But it's actually synchronous speed, which is generally not put on there. So we have some quick starts that I'm going to show you guys later, and we kind of give you what you need to do to pick out the motor poles. So most of the time, as I mentioned, you're going to be 4 poles or you're going to be 2 poles. Okay. So that's your motor data. Very important to set up before you do anything. Some people like to jump ahead and do like a trial run and check direction, but I at least recommend checking your motor parameters and making set them up right before you do any trial runs. All right, next up is your auto mode run command source, and then we're going to talk about frequency command source. So if we assume we're running a basic macro, so it's just general purpose, you start it, you stop it, you control the speed directly. Most of the time when you're running your VFD, you're going to be in auto. Okay, so auto mode is looking at two different parameters. It's looking at DRV 6 and 7. And again, you don't even need to remember the parameter names because again, you're just going down a linear list on the keypad when you first start up the drive. So it's going to say, where's your command source? And most of the time, and most of the calls we get, people are running P1 or P2 to run their drive. So those are terminals, and we call that FX for forward and then RX for reverse. Most pumps are just running forward. So all you really need for wiring is you need a contact closure, like a dry contact for P1 to CM. When you close that contact, the drive runs in auto, forward direction. Okay, so that's what this parameter is asking. You could set it to run off of the keypad. You could run it off of communications. There's a few different options, but most people just have a run relay that triggers the drive to start. So that's what this parameter is. And to follow on that is you always need two things to start the drive. You need a run signal, and then the second thing you need is a speed command. So your speed command is what we call our frequency reference source. It's the next parameter down, DRV7. Most of the time, guys are running either a 0 to 10 input or you have a 4 to 20 milliamp input. Okay, so here's some pictures on the bottom that kind of show you some basic wiring diagrams. 0 to 10 could be 2-wire or 3-wire. If it's 3-wire, it's typically because you have a speed pot, and the speed pot's a voltage divider. So that's the picture on the left here. It could be 2 wires. In that regard, you'd go to V1 and CM, with CM being your common. You'd go to this parameter and you say, hey, look at V1. Okay, so V1 is 0 to 10 for us. Contrary to that, you could be running a 4 to 20 milliamp, and that would go to terminal I2. So you'd go to the same parameter and you say go to I2, and then the drive looks at its 4 to 20 reference. So DRV 6 and 7, you're really just pointing the drive at, hey, what terminals are you going to look at to start and stop and control the speed? Okay. So you get through those two, that's your basic controls. And the next thing that pops up on the slide here is your XL and decel times. A lot of times people ignore these. I think our defaults are pretty conservative. I think we default to like a 20 and a 30-second XL and decel. But you will need to adjust that based on your pump type and your application. So we're going to have a slide that comes up later. If any of you guys do, for example, a submersible pump, you may be aware of there's a thrust bearing in that pump and you need to ramp up pretty quickly. So you can adjust this XL time, or you can put in a thrust frequency and a thrust time. So we do have a slide that comes up later on that. Whereas a lot of time, like centrifugal pumps, they don't need to ramp up that fast. So you can be a little bit more lax and you can leave these at 10 seconds, 15 seconds, 20 seconds, something like that. But those do pop up on this easy set. Next up is the stop mode. So by default, if you don't use any macros, you'll see this goes to like decelerate to a stop. So what that means is from 60 hertz to 0 hertz while you're ramping down from your maximum to your minimum. It's going to follow a pre-programmed time of 20 or 30 seconds, for example, which you could always adjust. But a lot of pumps, we don't really care how fast it stops. So we just set it to coast to stop. So most of the guys that I talk to, they're perfectly fine with that. So they'd actually go here and set it to coast to stop. And what that's going to do is it's going to shut off the output, and then the pump just stops on its own, based on inertia and friction. Okay. The last thing we'll mention here before we jump into the next group of setting parameters on basic setup is a reverse run prevention. So this is especially good if you have like a non-reverse ratchet type motor where you're not allowed to run reverse. Mechanically it's locked out. We have a reverse run prevent. So if you set this to reverse run prevent, even if we unknowingly try to run the pump in reverse, it's locked out via parameter. So it's impossible to run in reverse unless somebody takes the extra step to go into that parameter and undo whatever you did when you started it up. So that's a nice protection parameter that's built into this VFD, and it's in the easy start menu. So the last part of the easy start I'm going to mention, we switch gears into PID, which I think you guys will find interesting, is just some remaining parameters related to protection. Okay, so some of these are eye protection parameters, some of them are protection parameters for the motor. So the key ones we're going to talk about are phase loss detection, automatic resets, and then also the motor overload levels. Okay. So the top one here is phase loss detection. And we do recommend enabling this. Out of the box, they're disabled. So you could apply this for single phase and you could run it without a motor and the drive will be fine. But whenever you're ready to kind of finish commissioning this and put it in auto mode and run it, we'd recommend having these two bits up, which is the bit on the left for this parameter is input phase loss detection. So if you ever go from three phase to single phase by mistake and you clear a fuse or wire comes off, the drive's going to detect that. It's going to trip out to protect itself. And then the other bit is for pretty much motor protection. If a wire falls off or there's some issue in the motor, the drive's going to detect that and it's going to say there's a phase loss issue. Okay, so it's going to stop operation. Additionally, we could enable automatic resets on the drive. So you could set up to 10 automatic resets. So if the drive ever trips out, a lot of times for pumping stuff, people just set it and forget it. If it trips out, they want it to at least do some kind of restart. So you could scale that anywhere from 1 to 10 automatic restart attempts. And you could also pick out what kind of trips you want to do a reset on. There's standard trips such as like, motor overload, overcurrent, etc. There's low voltage trips you can enable. And then since this is a pumping drive, you could do automatic reset on a low feedback, a high feedback, set point timeout, overcycling, high flow, a flow accumulation. So there's all these checkboxes on the right here. So you can actually pick what you want the drive to do an automatic restart on based on what type of trip occurs. And the last thing on this slide is just ETH. So this is actually for a motor electronic thermal protection. And what it does is we do have, as we mentioned, the previously programmed motor current, which says, hey, if we go over our motor current, we're going to trip you out after a certain time. What this does is it looks at motor current, but it also looks at motor speed as well. So a lot of motors in this industry, just like pumping in general, are going to be self-cooled. So that means the fan is coupled onto the back of the motor shaft. So if you slow down the motor, well, then you slow down the cooling effect of the fan that's coupled to the motor shaft. So you can only run so slow before the motor starts to, heat up. So what this does is it estimates the motor temperature based on the motor type, the full load amps you programmed, and the speed. For example, if you look at this bottom parameter here, it says you could change it to force cooled. So force cooled is where you'd have like maybe 220 or something running to a fan that's so even if the motor is running at a low speed, that fan is running full speed. So you can get a higher current at a lower speed, and technically the motor is being properly cooled. So this is all stuff you guys could adjust. Typically the defaults are okay. This is a common trip we see, and people call us and like, hey, why am I getting this ETH? So, well, if you're running at a low speed and a high amperage, the drive's doing that to protect the motor. So the more you program into the drive, the smarter it is, and the better you're protecting everything, both the drive and the motor itself. So you don't need to be replacing anything from cooking a motor. So that was like general stuff there. What I'm going to explain next is a PID. So first off, what is PID? Well, PID is pretty much a process control loop, which is proportional, integral, and derivative. And a lot of times guys commonly just call it PI control because really you don't mess with the derivative too much. I've been doing this a while, and a lot of times I'm only adjusting the P gain and the I time. And if it's a bad day, then I'll be adjusting the derivative, but it doesn't happen too often. So as I mentioned, it's a mathematical process loop, and what you're doing is you're comparing two inputs. One is your set point, or as we call it here, a PID reference, and the other one is your feedback. So your feedback could be, a pressure transducer, for example. And what we're going to do is we're going to compare the two. We're going to calculate an error between the two. So if you have like a 60 PSI set point, but your feedback is at 55 PSI, what we're going to do is we're going to output a PID value after we go through this algorithm here, and we're going to adjust your motor speed to compensate for that difference. So in regards to a VFD, that's really all the PID function is doing, comparing a set point to a feedback and regulating motor speed to kind of get the two to match as close as possible, okay, to meet demand, essentially is what we're doing. And what we did is we made it as easy as possible. We actually have pressure control macro. So you power up your VFD, it says, hey, are you running pressure control? You select pressure control, and the drive actually guides you through everything you need to set up a PID loop, okay? So what you're going to be doing is you're generally going to be reviewing these parameters here. And the first thing we recommend setting is going to be your pressure transducer scale. Okay. So that's an important thing because if your scaling is not right, everything else is going to be wrong. Okay. So that's the first thing you want to do. So right here, we have a little picture of a 4 to 20 amp transducer. It's a pressure transducer that's rated from 0 to 100 PSI. So the first thing you're going to do is you're going to set the feedback source here to be I2 because it's a 4 to 20 milliamp. So I for current. And then you're going to go to the scaling and then you're going to set it to 100 PSI. Okay. So after you do your pressure scaling of 100 PSI, you could go to the next step, which is right here, which is setting up your set point. So your set point is what do you want to maintain? So I have a little picture down here where we're trying to maintain 30 PSI. So it's a pretty low pressure that might be good for like drip irrigation or something like that. Other of you guys that might be doing commercial or municipalities and stuff like that, you might be running 60, 70 PSI or, even higher. Okay. So you can see we have our set point on top. This is actual picture of a demo I have here where you see the feedback. And the feedback is pretty close to the set point, so the drive's kind of throttling down a little bit here. So after you have that programmed, you could run your drive in auto, which we talked about before. So, close your run command. And then the drive's going to compare your set point to the feedback. And if the feedback is below the set point, it's going to speed up to build up pressure essentially. And this is actually a good spot or a good time to compare your feedback value on the keypad to a mechanical gauge. So I tried to get a couple good pictures here of showing, hey, we have a 31 PSI feedback and we're at about 30 PSI on your mechanical gauge. It should be relatively close within a few PSI. If it's way off and just things are acting funny, that's when you're going to want to double check that initial scaling we talked about. Most of the time, guys have 4 to 20 milliamp transducers. Sometimes you have a one-off 0 to 10 volt transducer. So just make sure everything's programmed right for the transducer. That's usually what it comes down to if there's any issues or discrepancies there. While you're running this is also a good time to put valves. You could open and close and simulate demand change. Then you'll see the drive running up and down to maintain that pressure. Okay. So while you're doing that, it's a good thing to note that we could change our P gain and our I time. So as I mentioned, people call it a PID loop, but a lot of times you're only talking P and I, proportional integral time. Those are the two parameters that you'd most likely adjust if you need to fine tune the PID loop to make it any slower or faster, or just make stable operation in general. Okay. So this is accomplished with these two adjustments, and these aren't hidden anywhere in the drive's parameters. They're listed right in that macro group. So you have one group, you just go down the list and you program whatever you need. I recommend adjusting these parameters one at a time. You could actually make changes to these parameters while the VFD is running, which is great. Sometimes you got to stop the drive, change your parameter, run it. But on our VFD, you could change these on the fly. So we do PID setups all day. And if anybody calls and they're like, oh, it's a little bit sluggish, the first thing we would do is we would adjust this P gain. So it defaults to 50%, you could crank it up to 100%. I like the value of 200%. That makes it pretty responsive. So the gain is kind of like a sensitivity. You're seeing how sensitive you want to respond to the error. So the error is the difference between the set point and the feedback in the PI loop. Sometimes though, if you go too high, you just crank it up to the max, like 500, 600% or something like that. That could cause some instability and some oscillation because it's overshooting. It's like, oh, it's way too responsive. So I recommend increasing this maybe 50% or so at a time and seeing how it helps out. If you go too low, that's going to make things, less responsive, a little bit more sluggish. Okay, but I typically start with the P gain. Next thing I would do is if, hey, it's still not responding fast enough, I don't want to go too high on that P gain because then we could get some oscillation. Next thing I would do is the I time. So you can think of the I time as like a sampling rate. It's like how often are we checking the accumulated error between that set point and that feedback. So the shorter the I time, the faster it's going to respond because that sampling rate is shortened. It's happening quicker. So if you left this at like 10 seconds, that's kind of like a long delay. We're checking every 10 seconds the error amount. So you could set this at typically 1 or 2 seconds and it'll respond pretty well. Okay. Yeah, some critical applications may be running like 400% gain and maybe like a zero 0.1 or a 0.2 second high time. That's pretty extreme, but most pumping applications will be running like 200% gain and maybe a couple seconds on the eye time, and most people are happy with that. Is enough to get basic control going for PID. A few other things that we would add on, and these are very common items, is sleep and wake up. So sleep is pretty much stopping the VFD. So sleep is stopping the drive. You're putting it to sleep when there's a low demand period. So, I say nobody's flushing any toilets, nobody's using any showers in a high rise. The drive could shut down, and typically that's done based on frequency. So if you look on the left here, we have a few different methods for sleep type. I'd say most applications, maybe 90% are running on frequency. So if your frequency goes down, that's because the demand went down. Once we hit a certain frequency level and a delayed time, the drive will go to sleep. Then we have the opposite of that, which is wake up. So you can't go to sleep before you set your alarm. That's the best way to explain that. You need to set up a wake up alarm. And the wake up is typically a pressure drop. Okay. So by the default of our drive is going to be a deviation. So if you have a 60 psi set point and a 10 psi deviation, the drive is going to wake up after a 10 psi drop. So 60 drops to 50. Okay, pressure's low enough. Let's start up again. That's your wake up level. Okay. And these are customizable. I kind of like deviation because deviation follows your set point. So if you change your set point from 60 to 70 psi, it'll follow that with 10 psi deviation. If you want, you could change it to absolute. You could also customize your sleep level. You can make it based on output current. You can make it based on PID feedback value. You can make it based on speed as an RPM, or you can make it based on flow rate. Okay, so it's all customizable. The H100 Plus has the most options for all of this PID stuff out of all of our VFDs. Okay. So the next thing I have here is a short 5-minute demonstration that shows PID setup and operation. And what we're doing is we're using one of our other automation products, which is the LS HMI. So I'm going to go ahead and start this video.
So right here we have the LS HMI connected to the H100 Plus, which is the drive we're talking about. This drive's been programmed via the pressure control macro that we also discussed. So you can see here we have access to our set point, we have our feedback, and I have a demo that's right behind this, so I could simulate my feedback going up and down. Just like we mentioned on the H100 Plus keypad, we have our handoff auto buttons, so those are right here. All of these are mapped over Modbus, so we're actually communicating Modbus to the drive, and this is just a plug and play option. So for example, if I wanted to run in hand, I'd hit the green hand button. You can see that thrust mode message came up. So this has actually been set up with a thrust frequency of 30 hertz. So 0 to 30 hertz in 1 second to pretend that we're on a submersible pump. That'd be a normal feature you'd program in there. So right now we're just running hand. This is a good way to check direction or run while maybe you don't have pressure feedback set up and stuff like that. And you get it off, and then auto mode is actually going to run our PID loop. So before we do that, let's just go in and check our PID settings. So there's a few different things going on here. This is our home screen. So if you hit the home button, it just stays here. You have setup. And what we did is we broke down the common parameter groups into these buttons right here. So parameter initializing resets the drive. Here's your motor parameters, we mentioned that. Your drive setting parameters, how do you start, how do you stop, your I/O, your PID, pump protection, and then additional pumping settings in pump 1 and 2. So if I go to like our motor map, you can see this is set up for a 1.5 horsepower motor, 60 hertz, the motor poles, the RPM, the rated current, all the stuff we already discussed. And this is nice because it's just a point and click touchscreen. So if I want to change my motor capacity, I could just click it. Now I went down to 1 horsepower. I could go and I could change my rated current. Let's change it to, I don't know, 2.0 amps. There's your rated voltage, and then you could go back. And next thing, let's just see what this is set up for starting and stopping. So drive settings, we could see that we're running off of a terminals on this. Again, we mentioned that in these slides. And auto mode key is disabled, so that means you don't need to hit the auto key. Frequency reference source doesn't matter because I'm going to show you that we're running PID. So if I go back, I can see that PID basic, PID selection is set to yes. Our set point source, commonly called PID reference, is set to keypad. So that's just like a predetermined set point, most commonly what people are doing. In the real world, you'll probably be doing a 4 to 20 milliamp feedback on I2. In this case, we have a speed pot. We're simulating feedback. So I have it set up for V1, 0 to 10 volts. PSI is our units, 100 PSI is the max scaling of our transducer, and we have a set point of 60. So again, this is point and click. So I'm going to change it to 70 PSI and hit next. Here you can do scaling for your analog inputs. Specifically, this is for 4 to 20. Here's your P gain and your I time if you wanted to adjust those two values to improve or change how your PID loop responds. We also have PID input limits and I time. Those are for kind of limiting error and integral windup. And then now we're back to our main screen. So that's our basic PID stuff. So if I go to auto, and I'm going to flip on my switch here. Okay, so I thought thrust mode, and I can see my feedback is 33 PSI. So I'm below the set point, so I'm going to run full speed, 60 hertz. Pump is running to build up pressure. And as your feedback goes up, your frequency will go down. Okay, so that's a basic PID loop. So while that's ramping down, let's go to our setup and let's go to pump 1 settings, and we see we have our PID sleep and wake up, which are some other items we talked about. So sleep is 30 hertz. So minimum pump speed is also 30 hertz. So whatever one of these is higher, that's your sleep level. So actually sleep level is at 0, and then minimum pump speed is 30 hertz. So that 30 hertz becomes your sleep level essentially. There's a 5-second delay, and then there's a sleep boost, which typically I don't set up. Then we have our wake up level. So we have a deviation of 10 psi. So 70 minus 10 psi. That means we'll wake up at 60 psi. There's also some explanations here. So you can see, hey, if we have a pressure drop, it's a deviation from your set point, and then we hit this delay time, that's when the drive wakes up. Okay. So if I go back, so right now the drive is sleep because the feedback is high. The frequency dropped below 30 hertz. So now if I go 10 psi below 70, see, nothing happens until we hit 60. And now the drive thrusts up again and it starts running again. So that's a basic PID operation. This HMI is nice because it's a little bit more user-friendly than the keypad. Everybody likes touch screens now. Some other things we could see are in status. So we have trends. You could see your feedback go up and go down. Okay. You could also see frequency and current if you click those. Another thing you can see in status is you can see your I/O status. So right now I'm actually have my P1 and my P2s on. My P2 is set to none. P1 is FX, which is a forward run. That's my run command. I could also see my output status here with these little LEDs on here. You could also see under here trip log. So there's no trips here. The drive isn't tripped at all. You could also back up parameters into this HMI, and you could also do that on the keypad too. You could back up parameters. So that's just a little demo on PID. So I'm going to stop it.
All right. So hopefully you guys found that demo useful. Maybe if you didn't understand how PID worked, hopefully that explains a little bit. You also get to see the HMI. So that is a program that we offer. You just purchase an HMI and you can load it into the HMI and plug it into the VFD. So now what I'm going to do is I'm going to switch gears a little bit. So that was the end of the PID, just kind of like an intro to PID. So again, that was all in the PID macro. So all you gotta do is select the PID macro, and then the drive takes you to the rest, like almost like a wizard. The last macro, which we mentioned at the start of the session, was the lead lag macro. That's what I'm going to discuss now. So lead lag is essentially, it's a fully redundant multiple pump control operation. This is possible via two different ways. You could do like a simple contactor lag where you have one VFD where only one pump is variable speed, and then you're closing contactors for like starting up the other pumps. What I focused on here is kind of like the level 2 lead lag, which is multiple drives and multiple pumps. This is an advantageous setup because you're maximizing motor and pump lifespan, and you're mitigating pump wear because you have things in place such as staging, destaging, and alternation. Okay. So first, you should note that after you set up the macro, everything is fully customizable. So your staging and destaging levels, your on levels, your off levels, when you need more pumps, when you want to drop out pumps, is all fully customizable. Okay. Additionally, you could run analog feedback, or you could have network feedback, and we are adding functionality where you could automatically switch from analog feedback to a backup network feedback. Okay, so feedback is lost, you could look at feedback. So it's fully redundant in that regard. Additionally, you could do alternation based on time. You could do alternation based on number of stops. You can do a FIFO, which is a first in, first out operation, or a FILO, which is a first in, last out operation. And we do support jockey pumps. So I don't think I have a slide on jockey pumps, but that's like if you have, let's say, 3 pumps, 2 boosters that are 50 horse, and then you have a 5 horsepower smaller one that's like a pressure maintenance pump. You could have that 5 horsepower come on first just to maintain pressure, and then the boosters come on as a low priority based on a higher demand time. Additionally, we can do data share capabilities. So what that is one thing is displaying a network feedback device on all the VFDs as possible. And then also you can program one VFD, and that's going to share the parameter set on the other drives. So if you have a triplex of 3 drives, if you program the master drive, as long as you're doing it within the macro, most of those parameters are going to be shared into the other drives. So you don't need to set up the thing 3 times. Okay. So next thing I'm going to do here is to go show you how you would set up a lead lag setup. So lead lag setup, as I mentioned, is just selecting the macro. First thing you see, basic pressure control lead lag. This is the third option. So you select lead lag. Also, if you don't select it, that first startup screen, you could always go into the configuration on the drive and you can manually select your macro. The next thing you're going to need to do is you're going to have to enter in some of the key parameters here. If you're going to operate in lead lag mode, you're going to go into this macro mode, which we call macro 2. And then I'm going to show you on the next slide what parameters are within that macro. Okay. And the first thing you need to do before you set up anything is going to be your ID. So we're utilizing Modbus from drive to drive to drive. So if you have 2 drives, you're going to have drive 1, which is going to be address 1. Drive 2 is going to be address 2. So we default to 0, so it's a way of forcing you to put an address in there. So with Modbus, everything needs to be unique. So you need to uniquely say this is drive 1, this is drive 2. There can't be 2 drive 1s, there can't be 2 drive 2s. Okay, so that needs to be set up correctly. That's the first thing you do. We also recommend checking that you enabled your termination resistor on the last drive on the network. And the line resistor is what that is. That's built into the drive. You just got to flip the switch. And anytime I mess with communications, I like to cycle power. After you cycle power, there should be no communication errors anymore, because when you do first program this, you'll get a COM error until you set up your address appropriately. After you get all that squared away, then you can proceed with setting up your lead lag parameters, and that is on this slide right here. Okay, so these are the key lead lag parameters. This is all in the MC2. Okay, so now you can visually see what the macro group would look like, and you just go down with your down arrow on the keypad. Things you're going to see is, hey, what kind of lead lag operation are you doing? Are you doing a follow lead where everybody follows the lead drive? Are you doing a fixed lag where the lag drive comes on and it runs at a fixed speed of 50, 55 hertz or whatever? Or you're going to be doing network feedback, stuff like that. You can also see your FILO, your FIFO, your operation time order. You could also customize your alternation time. A lot of times, guys are just running 24 hours. So every 24 hours, the pumps switch. switches. So that's one way to mitigate pump wear. So this guy's not coming on all the time. We're actually switching it every day. So that's customizable. You go in here, you set up your number of pumps. And then when you get to this middle part of the list here, that's where you see your staging and your destaging. So staging is what do we need to program to pull on a pump? So it's typically based on like pressure, speed, and a delay time. And that's going to be the same thing for a destage. If our frequency goes low, our demand is met, and after a certain time, let's shut off the second pump, for example. So this is all fully programmable, so you can kind of customize it for whatever your needs are. And so that was just like a brief kind of introduction on lead lag. It's pretty easy, especially as long as you use the macro. The only hardware you need is you just need 2 wires to go from one drive to another, and that's the Modbus communication. And as long as you're set up with the macro, the drives are going to automatically communicate with each other and tell each other what they got to do, all based on the master drive. So I'm going to finish off here with some additional pumping features. So it should be noted that the H100 Plus has a ton of pumping features. We're not going to talk about them all, but I'm just going to mention some of the key ones. So here's some ones that you guys may be interested in. It's no flow control, pump overcycling protection, low-high feedback detection, set point timeout, a current limit function, backspin timer, a minimum pump speed can be set up, pump clean operation, soft fill, which we mentioned earlier, multiple motor control, which is contact or lag, a decel valve ramp if you have like a checked valve, flow monitoring and control, pipe break detection, underload detection, and thrust mode. So I picked out the most popular ones that we run into on a day-to-day basis, and there's a lot more. I just don't want to read off a long list, but you guys can do information like that on our website, our catalog, which we'll mention at the end of these slides. Okay. So what I did do is I picked out a few that we do on a day-to-day basis. These are all protection functions. High and low feedback detection is a very important one. Because these apply to both hand and auto. I didn't talk about hand so much, but hand is a basic keypad run command. So you hit the hand button, you ramp it up to 60 hertz, which is great. But the problem is if you're running a pressure control loop, hand doesn't really care about your pressure unless you set up a high feedback detection level. So you could say, hey, if I hit 90 PSI, I want the drive to shut off. I want it to keep running. I want it to flash a warning alarm. You have a level and you have a delay for both high feedback and for low feedback. You could set the drive to do a certain thing. Most likely you'd want it to stop before you like overpressure your system. So this function can be enabled within the H100 Plus. This is one of my favorite functions. We didn't have it on the previous generation, but we've added it to the H100 Plus. This is no flow control. So you close a valve and the pump goes to a deadhead situation. So this could happen when all the valves are closed. So there's no flow, but the pressure isn't increasing enough to lower the output frequency. Okay, so the drive effectively never goes to sleep. Or sleep takes a really long time to occur. So that could be an issue. Pump's just heating up. So we add this no flow control function here. It's disabled from the factory, so you'd have to go ahead and enable it. And pretty much it's a percentage. So you're setting this no flow control trigger bandwidth. And as soon as you enable that bandwidth, what we're going to do is we're going to monitor whenever we're within a certain criteria of the set point in our feedback and our time. So we have a time related to that. What we're going to do is we're actually going to actively adjust the output frequency and see what happens with the feedback. And then we can calculate if we're in a no flow condition. So this is a great improvement to our product lineup. I use this all the time, and I think we've replaced some specific competitors that are doing something similar here, but I've been told we've been doing it a little bit better, and it's really easy to set up. It's just a couple parameters. So no flow control, or you can call it like a deadhead protection, is a great function that's built into the H100 Plus VFD. Another thing you guys may care about is a backspin timer. So backspin timer, it's essentially like a run delay. So if you're running a vertical turbine and you stop it or you lose power or something, and the shaft starts backwards and the water column's falling down, you don't want to start into a condition like that. So a backspin timer is exactly as it sounds. Is you could set it to a very long time based on how long or how high that water column is. It's not going to let the drive run until that timer counts down to 0. We recently improved this, whereas to keep that timer going with the real-time clock, even if you lose power. So somebody shuts off power to the drive and then powers it back on, that backspin timer keeps going even with power off. So there's pretty much no way you can damage your pump as you set up this parameter. So this is another great feature. A couple more here is minimum pump speed. Pumps really don't do much work. They're not building up much pressure when you're running them at a low speed. So a lot of times we set up a minimum pump speed, 30 hertz, 40 hertz, depending on what type of pump you have. So that means even if you're telling the drive to go to super low speed, it's going to say, no, I'm not going to listen because you told me I have a minimum speed. Okay. Also related to that, we have a thrust mode. So for those of you guys that do submersible pumps, we have a thrust mode. Very simple thing. All you do is you program in your thrust frequency, which will be like 30 hertz, and it's going to ramp up from 0 to 30 hertz in 1 second. That's going to be fast enough to lubricate that thrust bearing. And then after that, it's going to follow your standard accel and decel time. Okay. This is great for submersible pumps. Okay. So I'm getting towards the end here. Just want to mention some of those protection features that we do on a day-to-day basis here. I just want to remind you guys that it really is easy. I went through a lot of stuff here. I went through a million functions, but if you utilize the easy set, which is built into the drive, it's like a widget. You got to know what macro you want to use, whether it's basic, pressure control. You select your macro, you just go down the list, you answer all the questions, and the drive is set up. Okay. We also have a lot of quick start guides that are available on our website. A lot of people, get that quick start guide and we never hear from them again. And I say, no news is good news. That means they figured it out. It's just a 2-page flyer that shows all the parameters we've been talking about that you need for a basic startup. So instead of opening up a 600-page manual, you open up this 2-page document. It shows you pictures, and you can see this picture here is actually, I stole some of those pictures from the previous slides. But it's showing you how do I scale a pressure transducer, how do I wire it up, where do I wire up my 24 volts. The drive has an internal 24 volts, so it shows you how you wire up that, power up the transducer. We also have a new website called our Solution Square. This is an automation product website. It's a knowledge base. We have manuals there. We have CAD files. You can go there. You can search like Quick Start, or you can search PID, or you can search stuff like that. It's going to show you some of the references that we use on a day-to-day basis to help out our customers. So just be aware of that. So speaking of being easy, we have a few different options for programming. If you don't like the keypad, you could use that HMI I showed you. So the HMI program is free to use. You just got to purchase the hardware. You just purchase the touchscreen from us or go through your local distributor and you dump it in. So that's a great tool that's available for you guys. It's point and click. It's a touchscreen. And then I think you have a couple more slides here. You could also use our software. So Drive Unite is our software. It's available on that Solution Square. It's free to download. It's free to use. The nice thing about the H100 Plus drive is we use a standard USB connection. So you don't even need to buy a proprietary cable from us. Get a USB cable, plug it in behind the keypad. You can read your parameters, write parameters, monitor stuff. You could do trending. You could export files into PDF and you could share it with people who don't have the program. The nice thing here is it's project-based. So you can make, hey, here's my simplex pump parameter set. You can take that, if you're an OEM, and you can dump it into, hundreds of drives. The options are endless. We also do have some YouTube videos. If you watch the YouTube videos, there's some videos I did, so you'll be stuck hearing my voice again. There's a few other guys here that have been really active at making YouTube videos. One of the other guys that I work with, he made a YouTube video that specifically shows PID setup. So the exact same thing we talked about today, but in a little bit further detail. He shows you how to go through the macro. So be sure to check out our YouTube page. It's the LS Electric America YouTube channel. We have overview videos, keypad navigation. We try to enable people to, kind of utilize the videos. People love stuff like that. And this is my last slide here. This is just our 800 number. So if you ever have any questions, you need technical support or like pre-sales stuff or certain things on applications, feel free to reach out to us via our 800 number or our tech support email, which is up here as well. Those are my slides. And now that we've reached the end of this, I know there's a litany of questions. So I think we could jump over to questions.
Yeah, so Stephen, thank you so much for that great presentation. And we do have a lot of questions. We won't have time to get to all of those today, but please feel free to keep sending those in. We'll get them to Stephen and the LS Electric team so that they can answer them offline. Just really quickly, attendees, if you would like a certificate of participation for today's webinar, you can do so by clicking the View Certificate button. And you'll also be able to see a recording of the presentation. You'll get that in an email later today where you'll be able to access the playback. But also feel free to visit pumpsandsystems.com for more on this topic and additional educational webinars. Of course, we'd like to thank Stephen and the LS Electric team for today's presentation. And thank you to everyone for taking the time to join us today. I hope you all have a great day.
Should we pick out some of the